All right, guys. Second set of notes. Similar polygons. So these notes, we are going to talk about basically comparing two different shapes and seeing how they are similar and doing math that goes along with it, obviously. So polygons that are the same shape but are not necessarily the same size are called similar polygons. So this is our symbol right here for similarity. Now you should recognize that because of our congruent sign. So basically congruence meant that we were equal in size and we were similar in shape. So if we take away the equal part and we just leave the squiggle on top, that means we're not equal in size, but we have similar shapes. So we're the same shape, basically, different size. So that's the symbol we will use for the rest of this unit. Two polygons are similar. IFF. No, that is not a typo. IFF stands for if and only if, meaning it's a double if. You have to have both of the stars below in order for the statement to be true. So two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. So both of these statements have to be true in order for the two polygons to be similar. So in other words, we have to have angle A congruent to angle E, angle B congruent to angle F, angle C congruent to angle G, angle D congruent to angle H. So that would suffice for the first one. Their corresponding angles are congruent. So each one of these, 1, 2, 3, 4. 1, 1, 2. These are the coatings if you forgot the little arcs. 3, 1, 2, 3, 4. Okay, so all angles have to be congruent and the measures of their corresponding sides have to be proportional. So what that basically means is like AB has to be proportional to EF, which has to be the same as BC and FG have to be proportional. And DC has to be proportional to HG. And then AD has to be proportional to EH. So all of the sides have to have the same ratio of proportion. All right, all of that has to be true for them to be similar. So let's go on to a similarity ratio or similarity statement is going to be written of the corresponding similar polygons. So basically what I just wrote out, this is how you would write it all as one. So all of those have to check off to be the same similarity ratio. All right, example 1. If polygon ABCD is similar to polygon EFGH, then polygon CBAD is similar to what? So basically, remember whenever we're going through congruent triangles unit, we had to have the same order in everything that we named. It's the same situation in similarity. So if we are going in order A, B, C, D, and then we change up the order to C, B, A, D, so that starts here and goes backwards, then we have to rename this one starting in the same spot, the same corresponding angle, which would be G, and we have to write the angles in the same order and the sides in the same order. So we have to do corresponding parts. So G corresponds to C, and then B corresponds to F. So F would be next, and then E and A correspond, and then H and D correspond. So they have to be in the same corresponding position whenever you write the name. All right, example 2. If triangle IJK is similar to triangle LMN, then complete each statement. So same thing, we're looking at triangles. Angle L is right here. It's the first angle. That has to be congruent to the first angle of the other triangle. They have, if they're similar, then the corresponding angles are congruent. So that would be angle I. And part B, same thing goes for sides. So if IJ corresponds to LM, then NM would correspond to KJ. Has to go in the same order, same sides. Alrighty? Now, given that the triangles are similar, solve for the value of x. So we're told that these two triangles are similar. So if these two triangles are similar, that means they have all angles corresponding are congruent and all corresponding sides are proportional. So that means we can set up a proportion. So that means 7 to 6 is going to be proportional. And x plus 3 to x plus 1 is proportional. Now, please notice that on the top here, I set up each time I started with the bigger triangle. You have to stay consistent with that. So if you put 7 over 6, you put the bigger triangle over the littler triangle, then you have to do the same thing with the other side. You have to put the bigger triangle, x plus 3, over the smaller triangle, x plus 1. You have to keep that consistent. So now we can cross multiply. And remember, if you have more than one thing, you have to distribute. So if we slow it down, that would be 7 times the quantity x plus 1 equals 6 times the quantity x plus 3. If you forgot that from the other day's lesson, from Monday's lesson, you have to distribute to everything. So we multiply by the quantity, so that'd be 7x plus 7 equals 6x plus 18. Now we can solve. So I'm going to subtract 6x. So I'm going to get x plus 7 equals 18. And then I'm going to subtract 7. So I'm going to get x equals 11 for my answer. Everybody good with that? All right, hopefully you're good with that. Flip the page. Find the values of x and y if triangle RST is similar to triangle JKL. So we have to match up the sides. So RS, so 5, RS is going to be similar to JK, so x. So I'm going to come over here. So that's, these two sides are proportional. And then ST6, and so these two are proportional. I'm going to put that one over here. Some of you are probably like, well, why are you putting that one over there? That's because it's got a y, not an x. So I don't really want to set it equal to my 5 over x. And then 4 over 7. That does not have a variable, so I'm going to put 4 to 7 on both of them. So we can compare the sides of the different variables with the ratio that's consistent in both triangles. All right, so I'm going to solve for x first. Cross multiply here. So that would be 4x equals, what's that, 35? So x equals, what's 35 divided by 4? Whoops, got to turn my calculator on. 35 divided by 4, 8.75. Is it okay to have a decimal? Yes, perfectly fine. Write the answer down. All right, let's cross multiply over here. So that would give us 4y plus 8. Remember, you distribute there. 6 times 7. Guys, I'm going to be honest, that is 1. I can hardly ever, I think it's 42. It's 42. I can hardly ever remember 6 times 7. Then I'm going to subtract the 8. So that would give us 34. And I'm going to divide by 4. So that would give us 8.5. All right, it is perfectly okay to get decimal answers. Do not erase them and try again if you get a decimal answer. Decimals are okay. Decimals are allowed. Decimals are our friend. All right, let's move on to the next one. Determine if the polygons are similar. So if they are, write a similarity statement. So we need a similarity statement and give a similarity ratio. So I'm going to circle ratio and statement. We have to have both of those things. If the polygons are similar, that means all angles have to be congruent. Well, let's look at it. We've got two right angles. We've got two 30, 60, 90 triangles. Okay, so we are congruent on all angles. So that means we're good to go on angles. So we can say angles are congruent. Check. That was the first part of our if and only if statement. So now we have to check and see if the sides are proportional. So I'm going to look 3 to 6. So they have to be corresponding sides. These are the two smallest sides in each triangle, so they have to be corresponding. And then 4, that's your medium side, to 8. And then 5, that's your hypotenuse, to 10. So I went long leg, short leg to hypotenuse. Now we have to make sure that all these are proportional. So 3 to 6, that reduces to 1/2. 4 to 8 reduces to 1/2. 5 to 10 reduces to 1/2. Check. So therefore, all of these sides are proportional. They all reduce to 1/2 ratio. We've done our work. Now we can answer the question. We've determined that the polygons are similar. If they are similar, it says write a similarity statement. So that would mean, whoops, I didn't put letters on here. A, B, C, D, E, and F. Sorry, guys. So our similarity statement, triangle A, B, C is similar. This is our similarity statement to triangle D, E, F. And then it wanted to know the similarity ratio. The similarity ratio is 1/2. So ratio, no, we don't write that. We write, the SR equals similarity ratio equals 1/2. Okay? Sorry, big yawn. Don't be afraid to pause and re-listen. All right, let's try and figure out B. We've got the coding. Opposite angles are congruent. So we are good there. So angles are congruent. Check. Now we need to figure out once again if these sides are proportional. So it looks like 4 to 6 and 5 to 7. Well, 4 to 6 reduces to 2 to 3. 5 to 7 does not reduce. So this is not a true statement. So slash through that equal sign. Okay, your sides are not proportional. So therefore, the polygons are not similar. Period. That's all the work that you need to show, is the fact that those two ratios are not proportional. They are not the same. They're not equivalent. So cross through that equal sign, and that justifies our answer. All right. Oh, wait, that's it. Is that it for today? Hey, that was a very simple and easy lesson. I hope you understood it. If you have any questions, once again, feel free to email me or Google Hangouts me, or go back and re-listen to this lesson again until you understand it. All right, we'll talk to you guys later.